Hello there, this is Carisi video tutorial. We're going to talk about generator functions. However, since we have to say quite a lot, we will not cover the generator expressions, and we will not also say anything about the send function. Otherwise it will last more than an hour. Now let's start with an example we have from the previous presentation. Sorry. We developed the class iterable3, and its objects can be iterables or iterators. As you can see, it has both dunder next and dunder iter methods. So in this class we just insert two function call, two print statements. The first one is here in line 47. It prints out a value before it returns it. Just it prints out calculated TMP before it returns TMP. And that's because we want to see when it is calculated, the timing. The other one is this print statement in line 52, which prints just a message, initializing, just to know when the dunder iter method is executed. Now let's go here and find out how we define it. We have an object A3, which is an iterable3 object, and it has 4 as an argument. I have to remind you, if you don't remember, what the iterable3 class, what its purpose. We supplied an argument, let's say a value, an integer, and provide us all the numbers from 0 up to that number. It's something similar to the range function Python already has, but without the start and without the step attributes. Now A3, it's an iterable object. B3, it's its iterator. We call it with a function iters, which calls the method dunder iter the object A3 has, which means that each time we call then the next method, the next function, the dunder next method is called, and it prints out its values. So let's see how it works. Now you have to pay attention on two things. Well, first of all, initializing is printed out just once, because in line 75 we just call the iter function. The first thing you have to pay attention more to notice is that it prints calculated 0 and then 0. Each message with calculated is printed out by the next method, dunder next method. Meanwhile, then it prints its value. So it's calculated, it calculates a value and prints out a value. Calculate the second value, prints out the second value, and so on. That's the first thing. The second thing, it does not calculate all the values. So since we provided 4 as its argument, it could also calculate the value of 3, but it does never do that because we don't require it. For instance, suppose that you have a list with 1,000 elements and you may not want all of them. You don't know this in advance, so why you have to calculate all of them? You don't. And that's a special case of an iterator, is called generator. So a generator is just an iterator that only calculates only the arguments if and when you need them. Now, if you want to see how this works in a for loop, here we have the A3 object as well, the same, that we don't change anything, and we want to print out the values with this message. The value is and the next value. Let's save it and let's run it. As you can see, initializing is called just once, the first time, just to initialize and to have the iterator of the A3 object, the iterable object, and it prints out those values. And you can see that we have a message from the dunder next method, you have a message from the print from the for statement, you have another, and goes on one after the other. Now we need all the values. We say a for loop, that's what it does actually. We don't have a break inside or something, so you obtain all the values. Now a quite significant question is, do we have to build every time an entire class just to have an iterator? And the answer is no. If you want to have a generator, sorry, we can build up a generator by just as a function generator. It's more simple. And let's build now our first generator. Let's make a simple generator to observe how the things are working on. Let's call it simple gen. It's a function. So anything you already know about functions already there. However, it has a special attitude. You can use a yield statement to return a value, but every time it returns a value, it yields a value. It does not start, the second time it will not start from the beginning. So we want to yield those three values, 1, 2 and 4. First time will yield value 1, then it will not start from the beginning of it, but it will start from the second line, already stopped in the previous call. So it will yield the value of 2 and then value of 4. If you want to see how this really works, you can just print list of simple gen. You can save it and run it. And you can see that you have a list with those three arguments, 1, 2 and 4. Of course, we could define it. We can instantiate it with another variable. Let's say gen equals to simple gen. You'll see that quite a lot of times, of course. And call it. It's the same thing. There is no much difference actually. However, it's preferable in a way that you don't combine lots of expressions in a single line. It's not a good practice. It's something that many students actually on their first step used to do, especially in C or C++ or whatever, but it's not a good practice in development. It prone errors. Now let's go a bit further and start write down a generator that really does something more useful. Let's write down a generator that just let's say double its values. We can supply a list and we return the double values of all the elements. We can call it double. It has as an argument values. Let's write down a print statement to specify when it starts. Writing starting and for value in values. We calculate the next value. We can print it out just to notice when this is happening. So with the methods calculated and value, and to yield, finally we want to yield this value to us. So that's all. Now let's define a list here and see how the things are working on. 1, 2, 4. That's enough, I think. And we can write down a print statement saying that we want to have the list of the double of the A list. Now, if we run it, we can see that you have the messages calculated 248, and finally that's the list 248, which are the double values from the initial list. If we had it in a for loop, it will be more useful to see how the timing they are calculated. For I in double A list, we want to print out vi. Oops, it's not Python 2, it's Python 3, I'm sorry. We need parentheses here. And you can see also the same thing we saw in the first class generator. Calculated value of 2, we have print out 2. Calculated value of 4, print out 4, and so on. Now, that's in our first actual generator that does something more useful. Let's make another one. Let's try to combine two generators. Let's see how these things are working on. Let's make a generator that adds a value. Let's say we want to provide this generator with argument values, and we want to provide some values as a list or another generator, values from another generator, and return all the values increased by a specific value, let's say 5 or something. So for valuing values, value has to be increased by 5, and yield value. Now I will comment this printout here, since we don't actually want this anymore. We don't need it now. And let's try to call it saying print that we want a list from the other generator providing the A list as its argument. Let's save it and run it, and you see that all the values have been increased by 5, 6, 7 and 9. We can also combine the generators. So if we want to combine the other with a double, we can write down, for instance, list of the other of the double of the A list. Do you like it? I don't. You see, we don't make such combinations. Let's see first the result and rewrite it down in a more pretty way. Well, its value has been doubled initially. If you don't understand it, get from inside to outside. Its value is doubled. The values, the original was 1, 2 and 4. 2 times 1 makes 2, plus 5 makes 7, and so on. And that's the other, plus 5. The most pretty way to write it down, as we said before, is to define a new I call it a silly name I gave actually here, I know, and I think parentheses are okay. So now we have split it in a way. We just have to say that that's the double of the A list. I think it's much more readable. Anyone can read it easier and does not hide errors. And of course we obtain the same result. Now let's make another step. We've already seen how we combine them, so let's now make another generator that just, let's count to infinity, starting from a value we specify as start attribute and goes on up to any value you want to. Let's call it my count. Since you see there is already a count function in the itertools, quite useful. That's our version of my count, count function, sorry. So defined my count, we can say while true, which is always true, and will never end. Yield the value of I, and increase I by 1. Simple enough. However, you can't call this with a list. Let's say list my count 5 or something, otherwise it will never end. You see, it doesn't end. It's always true, while true. So let's make another one. Let's call it first n, that provides us the first n argument of a generator. Let's first n from the generator G, and it has just to count down while the n is greater than 0, its value equals to the next g. Be patient here. If you've already seen something, you are in a good way. Yield the value and decrease n by 1. Well, from first, let's try to print out to see how the things are working, and then we'll see why it's not such correct as it should be. If we write down that we want the first 10 arguments from the, and how many arguments? Let's say that we want 6 arguments from the myCount function or generator, and we want those values to start from the value of 2, for instance. I think that's enough. Let's comment these. We don't need it anymore. We don't want to have many outputs. So those values starting from 0, there are the 6 numbers starting from 0, and goes up to any how many values you want to. Now it seems that it works, however it's not perfectly. We can see the problem if, for instance, we'll define a list. I think we've already got a list that has here, yes, it has 3 arguments. I'll add 2 more arguments, 6 and 9, so now it has 5 arguments. Suppose that you want a list with the first 10, and we want to have the 8 arguments from the A list. And let's see the error. You see, oops, yeah, it's another error as opposed to the iter. We have the iterator, this list, and now you can see 1, 2, 3, 4, another parenthesis here, yeah. Okay, that's the error we wanted to have here. The list has 5 attributes, 5 elements, and we require 8, and that's a problem. The problem here arises here in this next function call. Each time you are going to use next as a function call in any generator or in any other function, it's good practice to have it in a try block. Otherwise, you are lucky. It works just by luck, not because it's pretty well defined. So the most appropriate way to do that is to say try and accept stop iteration. If the iterator stopped, it has to write down a message or to just stop what it does, so you can print out a return statement. You can save it now and run it, and you see that it really works. It just provides you the first 5 numbers, although that you asked for the first 8, but there are no 8 elements. Now, there are other problems as well here. First, let's say that we want to close the generator. Of course, you can't close the generator meanwhile you are inside this generator, but you can close other generators that you are using. For instance, first 10 uses the generator of myCount, so it may be able to close this generator after it will end. How can you do that? We can go here and we can have a finally block, and in this finally block you can just write down that the G close. It's a method that closes the other generator, closes generator of G. Now, if we want to observe how the things works, let's comment this, save it and run it. And as you can see, we can't see anything different here, but in case that we wanted to have, let's say, our generator, suppose that you want to have the first, let's say that we want to have my count starting from the value of 4. Now in the first case you can say that you want from this generator the first 6 elements. You can also write down another print statement requiring a few more from the same generator. Now you require 4 more elements from the same generator. Let's comment this. Oops. Sorry, this, and see how it works. Let's save it and run it. You can see that in the first case, when we didn't have the closed generator, it goes on like that. It doesn't have any other. It's so provides us its arguments one after the other. First the 5, 6, and then the rest 4. If we uncomment the close, we also save and run it. You see now in the second case you have an empty list. And why is that? Because our generators has been closed. So it does not have any arguments, and the first 10 just provide us the next argument. If you want to have arguments from the beginning, you have to reinstantiate the gen as a generator of my count 4 or something, or any other value. So pay attention when you're closing, you're going to close a generator. Be sure that you don't want it anymore and go on like that. Now, there are cases that you have to close a generator, although it doesn't require lots of memory, since it does not store the values as you already seen, but it just calculates the value each time. But in case that you have many generators, you have to close them. Suppose, for instance, you have many seasons with users from a server. You can't leave open seasons there. You can't leave generators, as each season might be a generator. You want also in this case just to print out final close seasons function call. How you can do this in with many ways, but do never ever try to yield the value from a finally block. If you do this, you can't close a generator. Your generator will stay there in memory, so you have a problem. You'll have a problem. Do not, I repeat, try to close generator try to yield the value from the finally block in a generator. Now that's the important things to do. So you can also make here, if you don't want always to close it, you can have another attribute, or you can develop it as a decorator for any generator you may have. Let's say, for instance, closed equals to none, and here you can say if not closed or better, sorry, let's say better true and false. I don't want to confuse you guys. False. False will not close it, but if closed is equal to true, I don't have to write it down, then the generator has to close. So now each time you call this generator, you have to provide a third argument if you want to, otherwise it will not close it. So if you want to close this generator, for instance, you can say here, in this case, closed equals to true. You can save it and run it. And now, as you can see, in the first function call, the first generator call, we didn't close the generator, and when we want to close it, we just supplying this argument, it just closes the generator we're using. So I think that we've already seen how they really work. generator functions are really work. They can incorporate each other, and be careful, always try to have try, except, and finally blocks. They're pretty useful. Pay attention on the finally block. Even if you have a return statement, for instance here we have a return, it will always be executed just before the return statement. So it doesn't matter if you write it down underneath or something, if the finally block will always be executed before the return. And do never try to yield a value from the finally block, otherwise your generator will never be able to close. You have a runtime error. So that's all. Thank you very much. Be well.